All right, so this is our first lesson of the year. The first chapter is really basic, like really basic. So if you're after this first chapter saying, oh my God, I've done all this already, that's good. That's a good sign. You should have done all of this already in the first chapter. I can't presume that, so I do go through it pretty quickly, just to make sure that people can, hit on those topics if they have not seen it in the past at some point. So we're going to start with the number systems, like the real numbers in general, and then we're going to look at some graphs. And by graphs, I don't mean even two-dimensional. We're looking at like just simple number lines for today. Okay? We're going to talk about absolute value for a little while and some characteristics of numbers as well. So let's take a look at this first diagram here. I could actually, hold on, so we've got this idea of real numbers, and within the real number set, we've got classification. I'm sure most of you know what some of these are, but let's quickly discuss what they are and how you recognize whether a number is rational, irrational, an integer, a whole number, etc. So first we start with rational versus irrational. What do we see as a difference there between rational and irrational? What's the major difference in those sets of numbers that you maybe learned in the past at some point? Regina, go ahead.
Is it like rational numbers and they're like divided by another number, like irrational is like pi and stuff?
Okay, good example for the irrational and good explanation. Pretty much spot on there. Rational numbers have a terminating decimal, that's the phrase she was looking at there, it ends at some point, or a repeating decimal with a pattern. And as a result, as Regina said, they can be written as fractions. So rational numbers are either terminating decimals, repeating decimals, or anything represented as a fraction. That's what a rational number would be. And annoyingly enough, irrational numbers are kind of just the opposite. They cannot be written as a fraction. There is no pattern to their decimal. It goes on forever with no pattern whatsoever, such as pi, or the other symbol E you're going to see, which is right, 2.718. It's a limit that you'll be seeing later on in pre-calculus. Or something like the square root of 2. You type the square root of 2 in your calculator, you're going to see 1.414, and then from that point on, a lot of those decimals are just not arbitrary, but they have no pattern whatsoever. They almost look random, and they technically are. They're not random, but in a sense they're random. So irrational numbers, actually, there's a lot of them. The square root of any square that's not, or any number that's not a perfect square works. So square root of 8 works. The square root of 11, 12, 13, 14, 15, all of those numbers under the square root are irrational, except for the perfect squares. So like the square root of 16, what's the square root of 16? It's just 4. So obviously that's not irrational. But the square root of any non-perfect square, is indeed irrational. Okay, I'll use a pointer to make it a little bit better. But for rational, please jot down those three things for rational. Either it's a terminating decimal, a repeating decimal, or a fraction. Okay, rational simply means fraction, actually. So when you hear about rational functions later in the year, it means functions that are written as fractions. So you have a polynomial over another polynomial as a fraction. Within the rational numbers, we have subsets. What do we got for integers? What are integers? Go back to last year, yeah? So negatives and positives, what was the beginning part you said, Valentina? They're negatives and positives, but you need to be more specific and classify them a little bit more. Like, for example, is 2.5 an integer? Why not? It just can't have a decimal, yeah. Integers are numbers that do not have decimals, and they can be positive or negative. Okay, there's no decimal in there, and they can be positive and negative. Math is a language, right? So you need to know the vocabulary well. So I'm going to do this throughout the year, and I'm going to stress certain things that you should really be able to recognize, so that when later you talk about math or you answer questions in your college courses and in your calculus classes that you hopefully go on to take and stuff, you'll have a great vocabulary for these kinds of things. Whole numbers. Now, whole numbers and natural numbers are kind of annoying. It really doesn't matter which is which, but there's one distinction between whole numbers and natural numbers. You know what it is? Whole numbers include 0 and then all the positives. Natural numbers are just another word for counting numbers. So whole numbers are 0, 1, 2, 3, 4, etc. So it's 0 and all the positive integers. That's what whole numbers are. Whereas natural numbers...
No decimal for whole numbers?
Correct. Whole numbers, by definition, are whole, right? They are whole. There are no fractional portions to them. Okay, so that's the difference there. You pretty much don't have a zero when it comes to natural numbers. Nobody really cares about that as much. Okay, you should know rational, you should know irrational, and you should know integers like the back of your hand. Those are phrases and terms you will see in every calculus book and every textbook you're going to see from this point on. Whole and natural, not as important to be completely honest. Irrational, obviously, though, is also important. Okay, questions on this? I'm going quick, which is fine. Okay, please answer questions as quickly as possible, just because this is all review, so we can get through this kind of stuff today. So these are our definitions on the next page, okay? If you wanted to, like, you had examples in the previous one, but you like formal definitions, these are simply what we have. So the unpredictable nature of decimals causes an irrational number. A predictable decimal causes a rational number. Or again, we say we can write it as a fraction, and then the other ones are listed above. Good? All right, let's press on. So number lines, we need to know what number lines are, the basics of them. Number lines go from negative infinity to positive infinity, and they pass through zero. You might only be interested in a certain portion of a number line. A number line is really an x-axis. Think about the x-axis. The x-axis itself is a number line. When you look at a coordinate plane where you have x and y-axis, it's just two number lines. That's all it is. Okay, that's all we're looking at here. Yeah, I wrote here it's commonly used in history class just because it relates things or quantities that are greater than another. So you use it a lot in history with time. Okay, that's all you have for that. Let's go on to the next part here. So let's take a look at this first example. So we want to find the coordinate of the point that is 2/3 of the way from A to B. 2/3 of the way from A to B. Take a minute to look at this. Try to come up with a solution if you can. We'll go over it together. And I'm not going to, so you can raise your hand to answer, but when I see you stop writing, I'll assume you're done, so I'll literally nice keep looking around. So I'll give you guys a little bit of time to work on it so I can see that everybody's ready. I'll put a hint up in case you're struggling at all. So the hint is that these are 6 units apart, right? -2 to 4 is 6 units apart. And I want a point that's 2/3 of the way from A to B. So I want to start at A and go 2/3 of the way to B. I don't want to go, all the way from A all the way to B. I want to go 2/3 of the way. So this is about half. I want to go somewhere in this region, right? So what approach did you take here? Name again.
Alex.
Alex. Okay. Alex.
I
Good.
just counted 6 units.
Okay.
You just do 2/3 of 6.
And
that's
of means what in math?
divide or multiply.
Good.
And then use it from A to B would be at 2.
Very good. So I'm going from A to B. So I start at A, I go 4 units over, and I'm at the point that I'm looking for. And make a sense of this. Split up 6 into thirds. 6 in thirds is 2, 2, 2. And I can see on the board, if I look, I've got a distance of 2 right here, a distance of 2 right here, and a distance of 2 right here. So this right here is 2/3 of the way from A to B. Clear? Easy. That was an easy one, right? Let's go to the next one. It's not as easy. And you might think it's easy, but it's actually not as easy, this one. So think outside the box here. I'm assuming everybody's going to get the first answer. The question is, can you find the second answer? There's 2 answers here. So for those that think they're done, try to think about the second answer. The first one is really simple to get. You can look and just see the answer. The second one is not obvious. Hey, second row. Are these font sizes big enough? I just reformatted because this program has changed a lot. And I'm going to be editing my notes all year to change so the program works. So I can change the font size. Would it be better to be a little bit bigger? What do you think? You all have like perfect vision? Well, you have glasses on, so I'm sure you can see it easily. Just nervous that it's a little bit small from the very back. I don't know. Like I have bad vision and I have trouble seeing that from the back. I'd have to squint. All right. Maybe I'll make it a little bit bigger. But you guys can see from the second row? Okay. Hey, what's the first answer? The easy answer. Just call it out. What is it? What is it? I heard different answers from all of you guys. What's the point that's half away from A that it is from B? Not -2. That's halfway between. -3. -3. Half as far from A as it is from B. So if I look at this location right here, this is 2 units from A, right? And it's 4 units from B. So it's half as far from A as it is from B. It's 4 units away from B, and it's 2 units away from A. So this is actually the answer that most people get to start. But there's another answer that's correct. Again, read the words carefully. It doesn't say it's halfway between A and B. It says it's half as far from A as from B. So the distance from A here is 2, while the distance from B here is 4. So that answer is correct. -3 is one of them. -3 is one of them. Alex, what do you think? You got a hand? Still thinking? Let me see what you got. I want to see what you wrote down for the other one. Why? Figure it out. Okay, yeah. You see how that's not it, right? But you're on the right track, Regina. Keep on that. So Regina, do you mind? Yeah. Regina put down -7 and thought, oh, that's 2 units away on that side. That'll work. She had the right idea. That's definitely on the left side of A, the other number. That's a hint if you want. The other answer is on the left side of A. You could obviously sit there and do trial and error and try numbers, right? Yeah. No. Be careful. I think that's it. Hold on, let me see. Yes, that's good. Yeah. Close, huh? I'm going to show you a mathematical approach to this, by the way, instead of just guessing and checking right now. So feel free to just look, and a lot of you are doing that. You're just counting spaces, which is fine. It happens to be nice, this problem, because everything, the answers are integer values, so it's nice and easy to count. Anyone have an answer besides Regina? I saw hers was right. She's just doing trial and error to figure it out, though, guys. So you can use trial and error to help you. It's going to be on the left side of A. Why is it going to be on the left side of A? What does it mean when it says half as far from A as it is from B? Which one is it really closer to, A or B? It's closer to A. I mean, look at the answer here, right? This was our first answer, and it was closer to A. It's half as far from A as it is from B. So if I put a point out here, it's clearly going to be closer to B, isn't it? But we can see here that our answer should be closer to A because it's half as far. So the answer has to be on this side somewhere. It's got to be on this side. And you could just keep trying numbers from left and keep checking the distances every time. There's another way to do this, though, I think might be a good approach. So if you want to pause your guessing and checking right now and just take a look up, I'm going to prove the first one to you with an algebraic approach. A lot of you, did anyone use an algebraic approach for this? Or did you kind of just see it? Because you can visualize it, right? You can physically see it, like solving by inspection while you just look at the figure. Well, clearly -3 works. That makes sense, right? But how would I approach this? So here's what I would do. Call a location in here somewhere X. We don't know where the location is, but just call it X for now. How do I find the distance between X and A? How would I don't know what X is, whatever it is. How would I find the distance between X and A? What's the distance between 3 and 5? Everybody. Between 3 and 5, what's the distance? How did you get it? 5 minus 3. Like, what's the operation really, right? You say I counted 2. So you subtracted, right? You took the bigger number minus the smaller number to find distance. So if X is somewhere in this region, and I want to find the distance between A and X, I will take the bigger number minus the smaller number. So what would that be read as? X minus A. That's the distance between X, that point that we're looking for, and A. Stay with me for a sec. Now, the distance between x and b, because x is in this region somewhere, b is bigger than it, isn't it? So how would I use the subtraction operation for this one? B minus x. Now, you were told in the directions that the distance between x and a is half of that between x and b, right? The unknown spot. So what would I set this equal to? Well, it becomes 2 and 4, right? This distance becomes 2, really, and this distance becomes 4. What's 2 over 4 really, though? Yeah, and that makes sense. Look at the directions in the beginning. It says, again, the distance between x and a when compared to the distance between x and b should equal 1/2, right? So this is just a ratio of numbers. So this is the one distance, and it's got to be half of whatever this distance is itself. Maybe this is 2 and 4, 3 and 6, 4 and 8, we don't know. But it's going to reduce to 1/2 in the end. So this is the way you would approach this problem. If you solve this proportion by just simply cross multiplying, you're going to get -3 as an answer. That was the first answer we got. How would this change if x, instead of being in here, if x was out here or out here? In this case, it's out here on the far left. How would it change, again, if x, instead of being in this region, is somewhere out here? What would happen? Very good. So it would just be a minus x over b minus x equals 1/2, which, believe it or not, gives you a different answer. So those are the two equations you would solve. The one in red, when you solve it, you're going to get -3 as your answer. The one in green, you'll get -11 as your answer. Okay, you should be able to solve an equation like this. If you're having trouble with it, just cross multiply. Okay, this one will become b minus x equals 2 parentheses a minus x. I need to then distribute the 2, collect terms. My goal here, I know what a and b are. I can plug them in. A is -5, b is 1. So replace the a and b values with their coordinates from above. I'll move down so you can see it. There you go. Okay, replace a and b with their coordinates and just solve for x. So you end up getting 2 answers for a problem like this. And this was a problem, I think, that was on like one of those math competitions where the intuitive thing is to get this answer, right? This is the one that makes most sense because it's somewhere in between. Finding the one that's outside of the region, well, it doesn't really, it's not as obvious as the other one is. But if you check and take a look at it, you can see it's actually correct. You can just plot the point -11. -11 to -5, that's 6 units apart. Well, that's 6 units apart. So from -11 to 1, that'll be 12 units. So it's 6 units from A, and then it's 12 units from B. 6 units away from A, 12 units away from B. The question said it's half as far from A as it is from B. So as a result, we can see that this answer is correct, even though it's not obvious. Okay, it's not obvious. It's not the one that shows up right away. I gave you one in the homework to practice like this. Okay, use this as a model. It will help you. This is also going to introduce us to the idea of absolute value in a minute. Absolute value being distance also. So we'll see how that comes into play. We could have used absolute value symbols, but because we haven't introduced it yet, I didn't use it for this problem. Okay, we're going to see absolute value. Inequalities. If you recall, inequalities are just statements that compare two quantities. Statements that compare two quantities. Like obviously 7 is greater than 4. You know that. 7 is a greater number than 4. It's simply further to the right on the number line. That's all it means. Any number that's greater than another just means it's further to the right. Any number that's less than another means it's further to the left. That's the easy way to remember greater than and less than. Don't start, because people start thinking negatives, and I've seen students answer questions like, well, -20 is greater than -5. Well, the value 20 is bigger than 5, right? But -20, that's actually less than -5. It's further to the left on the number line. So whenever you use inequality statements, visualize the number line in your mind to make sure that your inequality statement is drawing the correct direction. This is really quite simple. Graph the numbers -0.5 and 5 on a number line and write an inequality statement comparing the two. I'm going to do it with you because it's that easy. not drawn to scale, I apologize. That's done poorly. There we go. Okay, those are the points in the number line. Whichever is to the right is the bigger one. So by default, 5 is greater than negative 0.5. And you know that. That's common sense, which is why I said this is one of those easy ones. Okay, that's all you're literally doing. 5 is greater than negative 0.5. Stop me if you have a question, please, okay? So just let me know, or else I'm going to keep going through. Let's go to slide 9. So absolute value. Remember the definition of this. When you think of any number and you're finding the absolute value, picture the distance from 0 on the number line. This will come up to play a role later on in your pre-calculus course for sure. It's important that you understand absolute value, not just memorize, oh, take the positive number, right? When you're younger in math, you're told absolute value just means use the positive number of whatever's on the inside. But what if inside of absolute value is a variable? Then it makes it a little bit trickier, right? So we're going to see more of that in this course. Where in the past you've done things like, oh, the absolute value of negative 5 is just 5. Why is that? It's because the distance between negative 5 and 0, what is that distance? It's a distance of 5. So absolute value is defined as simply the distance between that point and 0 on the number line. Now, this is something that you want to consider. Absolute value, I think if I wrote this, did I put this on the note? Absolute value as a function can be thought of in pieces. So for example, if I wanted the absolute value of x, okay, I can think of this as pieces depending on what x is. If x is positive, such as positive 5, well then the absolute value of x is just simply x. But if x is negative, for example, let's say x is negative 7. Well, this answer becomes positive 7, right? So when x is negative, let me actually move this down a little bit. I'm going to put this guy down here. When x is positive, we know it's positive x. But when x is negative, the function is actually negative x, meaning you're going to use the opposite if it's negative. But if x is positive, like 7, you would just say, well, absolute value of 7 is simply 7. But the absolute value of negative 7 is positive 7. So if this were a negative 7 in here, you got to do the negative 7, making that positive. So absolute value can be thought of in little pieces. What's the absolute value of 0? Simply 0. So when x is 0, we have to worry about that. So here's how we write it. We use domain notation, or set notation for the domain here. When x is less than 0, when x is equal to 0, and when x is greater than 0. So this is kind of a first introduction into what are called piecewise functions. Raise your hand if you've heard that phrase before. Piecewise functions. So piecewise functions simply mean the function is written in pieces along the way. So if I had a piecewise function, it means that if I were to graph something like this, I would graph everything where x is negative as the first function. When x is 0, I would just graph 0. And when x is positive, I would graph the function x. So that's why the absolute value function, it turns out, you're going to see this more later, looks like this. When x is negative, the absolute value function is the function negative x, which is a falling linear function. When x is equal to 0, the actual value of the function is 0. That's 0, 0. When x is positive, the function is always positive, or it's equal to x, which is this positive increasing line. So when we think about absolute value, obviously remember that when you have a negative, it becomes positive. So when this value is negative, you need to take the opposite of it, which is what this is saying right here. When x is negative, take the opposite of x. When x is positive, use x itself. Okay, use x itself. All right. So quick examples. All right, quick examples. Please remember PEMDAS. Please remember to do the absolute value first before you perform any operations. What does the first one become? What's the first one become? What is the name again? Sorry. Francisco. 18. Very good. Because the absolute value of negative 6 is just 6, which makes that 18. The second one. The second one. Valentina, go ahead. Good. So we got 4 minus 7, which is negative 3. Again, take the absolute values to start. And the last one. We're getting 2 because we're going to see that it's really absolute value of negative 2 which is indeed equal to 2. Very good. Okay, so perform the operation inside first. 3 minus 5 is negative 2. If you have to do that, it's positive. All right. So let us press on to section 1-2. Again, I told you this earlier, this is going to be a bit of a review, so I hope you're doing well with this stuff. Here's your homework from 1-1. It's on the next slide, right? You notice that? Did I talk about these videos already? I did, right? Okay, good. So if you need more help or if you want extra stuff on top of what we learned, the asterisk is usually kind of more advanced stuff. This is in the textbook, the one that you just got. Yep, that's correct.